All right, let's take a look at the post.py program, and I did a layout here, a visual layout. So here is the superclass ship. Here are the child classes or subclasses of the superclass ship. We have Amazon and FedEx. Now the distance or instance, shall I say, variables of ship include alpha and numeric, and they are there to create random product numbers or tracking numbers. Now taking a look at this class, the parameters are prod ID and quantity, and the instance variables or things we know include the strings alpha and num, and I'll explain that in just a second. The things we can do or the methods include post, sell, and mail. Again, this is the post.py program we've already seen. Now the first subclass, Amazon, we're using ship as its parameter because this allows Amazon to adopt or inherit all the assets under ship, but it's also adding the method return. Now the parameters of ship include prod ID and quantity. Finally, we have the FedEx subclass, and FedEx becomes a subclass and inherits all the assets of ship because it puts ship in the parameters. Now in the class itself. Now in terms of the constructor, there are no parameters of FedEx. So let's take a look at what this looks like in terms of coding. I wanted to make it clear to everyone we are actually going into a .py file right here using Vim as the text editor. This is specific to Unix or Linux systems such as Debian right here, or if you are on a Mac OS. However, if you're on Windows, you have to go to Notepad or Notepad++ or VS Code. Looking at this programming right here is the class ship, and this is right now acting as a superclass to Amazon because Amazon is in fact using ship as its parameter. So it is inheriting everything within ship. So what exactly is Amazon and what are Amazon and FedEx actually inheriting? So you take a look at the class ship. We have the distance variables including alpha and numeric or just num, and we have a constructor class or a constructor method right here in which it requests prod ID and quantity when you call to class. And then we have post as a method and another method sell and another method mail. And under class, we do have an initialization method right here calling for prod ID and quantity when you call to Amazon to instantiate that as a class. The only method specific to Amazon and Amazon only is return. And under FedEx, really, there are no methods that are specific to FedEx that aren't also in Amazon except for its initial constructor information. And we have the order number, which it asks you to input the order number. So let me go ahead and prove to you that in fact Amazon is actually a subclass of ship. If I leave the text editor, and I go to if I go to Python 3, which is my idle or my interactive mode in Linux. Okay, so if I call and create an Amazon object, meaning I reference the Amazon object and I create shipment 123 and I make a reference to the .amazon class right here. If for example, I just have an empty class and if I call to the Amazon class with no parameters, it's going to give me an error because it's saying it's missing two required positional arguments. Now, if we go back to the Amazon class, it is in fact, because of its constructor, asking me to include prod ID and quantity. So let me get out of here and let me go to Python 3 again, and let me import post, and let me go ahead and again redo this, and you'll see that is an error. So it's looking for me to put in the prod ID and the quantity. So the prod ID is going to be shipment 123, and let's say we bought 100 of them. So now we have successfully created that object, and the order number is shipment 123, and then it does give us an Amazon shipment complete with this number right here. However, let's take a look at shipment 123 as an object, pressing the tab, and I can see that it it has the .num, the .quantity, the .cell, the .post, which were only in the ship. Now, if I typed in exit and I went into this and I actually edited this, let's go ahead and take a look at this Amazon ship, and let's remove the ship from the Amazon parameters. Now, right now, Amazon is no longer a subclass of ship. Do you see how I did that? Let's save that, and then let me go back into idle, and let me again go import post, and let's create that same shipment. Enter order, shipment 1, 2, 3, and it does in fact do its job. It does create Amazon shipment 1, 2, 3, 5, 7, but let's take a look at this object, and we can see, look at that. We only have .return at our fingertips, whereas before we had sell, post, and mail. Well, let's see what changed. What changed is that only shipment has access to post, sell, and mail, but we don't, because we took the fact that the ship was the subclass, or was the superclass of Amazon. So let's change that. Let's put ship back into the Amazon parameters, and we can see the effect of this. Let's go ahead and import ship again, import post, I should say, and let's do this again, and let's say any order number right there, and let's look at shipment 1, 2, 3, and look at this. Because now we have made Amazon a subclass of ship, in which we now inherit all the ship's classes, all the assets in it. We can see that now we can sell, we can mail, and we can post as well as return, as opposed to the old way of doing it. We just had return. We just had access to returns. So the moral of the story is that in order to inherit from the superclass, you have to indicate that in the parameters of the class. So let's focus on the Amazon subclass, and the parameters that we need to have in place to instantiate the Amazon class include a production ID or prod ID and the quantity. Now, the only methods that are available to us in Amazon is the return, but because of inheritance, because we're inheriting the ship class, we also have access to all of the assets right here, including the methods post, sell, mail, and then the instance variables alpha and num. So, but what good is alpha and num doing? Like, what is going on in the Amazon class? Let's take a look at what the code is telling us. We can see this is the Amazon class, and we can see that the parameter is calling on the fact that it's inheriting everything in the ship class, all the instance variables and the methods. But what is the Amazon class itself doing? So when we initialize it, this is called the dunder special initialization or init method. That's called a dunder method. It's actually a constructor. What a constructor actually is when you instantiate the Amazon class, when you create the object, this actually represents pre-baked actions that occur in that method. So it automatically calls onto us to actually enter the order number here. But interestingly enough, because we need the initial product ID to even instantiate the Amazon, isn't it weird that it then calls us to enter the order number here? So it is kind of redundant. But here we have code 1. So it looks like what's happening is that there is a code that is created. How is it being created? Well, it's calling on the random choice from the ship.alpha. So in other words, it's referring to the ship.alpha instance variable right here. And it's also saying that it's taking a random choice of a character from this string right here. Same thing with this one here, calling for the ship number. So it's taking a random number out of this string. And then it's saying Amazon ID equals AMAZ, and it's concatenating the order number, and then it's concatenating the code that was created here, and then the code that was created here. So let's go ahead and instantiate this Amazon very quickly. Let's go to the idle, and let's go ahead and import post, and let's take a look at how Amazon is being instantiated. So we instantiated right here post.amazon. Now notice we actually have to preface Amazon with the post dot because of how we imported post. That was talked about in a prior video, and it's saying that I have to have the a production ID right here. So let's just call it Blu-ray 34, and we'll say it's the season 1 of Ray Donovan. I'm just going to give you that as an example, and of course I'm only ordering one. Enter the order number here. So again, let's call it BR for Blu-ray, and let's say it's item 344. It's Ray Donovan season 1, and here is the Amazon completed Amazon number AMAZ. So this is in line with the Pride ID, and then this is the random letter that was created and the random number. And if we actually do it again and we enter the number here, and we can see that it generated another random letter X and then a random number 1. So what kinds of things can we do with the FedEx subclass? Apparently there's no parameters, so that should be consistent with the code. And here we can see that the FedEx does in fact have no parameters, because in the constructor method there is no parameters within the constructor method, as opposed to the Amazon method in which there's prod ID and quantity. So when we instantiate the FedEx class, creating a FedEx object, we don't have to include a prod ID or quantity, but during the initialization method, it does ask us to enter the order number, and then it does do what Amazon does. It does generate a code or FedEx ID, as you can see. And here we use the modified print format command right here, as opposed to just using concatenations as we did for Amazon, or the commas. So let's take a look at this. Let's get out of here and let's go to the Python 3 idle, and let's import post. And instead of importing an Amazon, we're going to import FedEx. So we'll just say shipment 456 is FedEx, and we can see that there are no parameters. But when we press enter, it does begin to proceed with that initialization reference, or that initialization method, and it says welcome to FedEx, enter the order number. So we'll just say order 456, press enter. Thank you for shipping with us. Your ID is order 456. And again, if we did shipment 456, we can see that again we have access to the alpha asset and the .num. These two are instance variables, and then we have .mail, post, and sell. Those are methods, but keep in mind those are methods that we inherited from the original shipping superclass. So now we have to ask ourselves the existential question: how do we know what actual objects to create? Because in this example of the post.py program, we programmed it, and we know by now, probably off the tops of our heads, what the superclass is. It's ship, and what the underclasses are, or what the child subclasses are. It is Amazon, and the other class is FedEx. But unless we wrote it, in which case whenever we input or import a class, we hardly have ever written it, right? So this is an exception because we wrote it. We know what the class names are, but wait a second. If we import a class of which we didn't write, which is most of the time, how do we know what classes we can create or we can instantiate? And also, when we instantiate that class, thus creating an object, how do we know what parameters to add? So let's take a look at how we can do that. All right, let's go to our interactive environment. I'm going to idle right now, and I'm going to import that program or that file called post, and then we can call the help function for that program called post. And in this help function, it will show a broad overview of all of the classes and the parameters that are needing to be called for those classes. We have the superclass ship and the subclasses Amazon and FedEx, but we also see that it mentions the parameters we have to instantiate them with. For example, the Amazon class clearly shows the Amazon class needs to be instantiated with prod ID and quantity, whereas the Whereas the FedEx class, it clearly says the FedEx to be instantiated with no parameters. And it also shows the method resolution order. So the method resolution order for Amazon says in order of priority, Amazon, ship, and all the built-in objects. So in other words, if there's a method, and we can see the different methods here, mail, post, and mail, post, and sell, it clearly says methods inherited from ship, but it's entirely possible that the Amazon class itself might have a method defined with the same name, mail, post, or sell, since they're commonly used terms in the supply chain lexicon. Now, the method resolution means that if there's a method with the same name, as in Amazon itself has the method called mail, except the mail wouldn't necessarily be inherited from ship. It would have different activities under the Amazon version of mail, but guess what? The Amazon version of mail has the same method named mail as ship. So what this method resolution is saying is that it will take the locally defined version of that variable name or method name over and above the inherited definition of ship. This is to make sure and to resolve any inconsistencies or resolve any redundant names. So the order of resolution is the local method right here, which is Amazon, and then the inherited method, which is ship, and then if there happens to be any built-ins. So if you have the same method name or variable name of a keyword already, it's going to resolve the local name first and then everything else. Now the question is, how does it know that Amazon needs to be instantiated with prod ID and quantity, for example? And keep in mind, there's helpful text under here, under the FedEx class, that says FedEx to be instantiated with no parameters. Well, we can go back to the code and we can see that we put our friendly doc strings right here. So under Amazon, we have the triple quote doc string that we actually typed it in. Amazon needs to be instantiated with prod ID and quantity. So these doc strings are available to us. The purpose of the doc strings is that they are available in the help function of idle.